Okay, so let's now talk about the other, other definition of competitive equilibrium. Okay, so this is a second definition. Okay, so let me clear this. So for the second definition, we have a different story. Okay, so it's not like individuals are actually buying public good separately in this way and then combining their purchase and then consuming it together. That's not what is happening. Okay, uh, it's basically, you can imagine a scenario where, let's say for example, there is, yeah, say for example, those two roommates are interested in hiring someone for for, let's say, someone for some household work. Okay, or you can say maybe in some society, the people in the society want to hire a security guard. Okay, who is just going to uh, provide his security services to all the members of the society. So you can imagine a scenario like this. So obviously, you cannot have uh, people actually buying the security services separately and then combining them and consuming them together. That kind of story doesn't fit well here, right? But if you really think about these security services, they are like public good, because from the society's point of view, because once the service is in place, it will be available to all the individuals in the same quantity. Okay, and there is no possibility to exclude anybody. Okay, so it's non-rival and non-excludable, so it is a public good. Okay, but you cannot imagine that people are actually buying some amount of security services separately, and then combining them and consuming them. That kind of story doesn't fit. Okay, so what we can do is we can have a different story here. Okay, where you know where again, it's the same model. Okay, we'll have some production function which is going to give us the public good. Again, it's a private ownership firm. It's the same model, no difference at all. The previous one and this one is the same model. The only difference is now individual will be paying some fraction of the price. Okay, so let's say if uh, you know PG is the price of the public good, then individual one will pay some proportion of it. Okay, and individual two will pay some proportion of it. Okay, is that clear? Make sense? So like for example, if PG is 2 and individual one pay 1, individual two pay 1. Okay, so that's like 50-50. They split 50-50, and 50% is paid by 1, 50% is paid by 2, and the firm that is providing the security services, in this case the security guard, will receive P1 plus P2. Okay, where P1 is 1 and P2 is 1, so he's going to receive the sum of the amounts that are paid by the individuals. Okay, so each individual will pay his own individual price. Okay, you can also imagine, this is the kind of thing which happens even, if you really think about more generally about the public good, the goods that are provided by the government. Okay, they actually take taxes, right? I mean, government take taxes, so tax can be thought of as it's an individual price. Okay, so each individual pay a different price, even though they all get the same amount of public good. Okay, but each individual is paying a different price. Why is each individual paying a different price? Because if you see, the tax is not, it's not a constant, right, across individuals. It depends on income. Okay, so each individual actually is paying a different price, and each individual is consuming the same amount of public good. Okay, so if you keep this story in mind, it's just going to fit well. Okay, now we are going to define the second definition of competitive equilibrium for these kind of public goods. Okay, so so uh, So let me give you the definition now. Okay, so again, I'm going to come back to our model, which is two consumer model. Okay, and I'm going to give you the definition. Okay, so we can call this competitive equilibrium definition 2, or we can also call this Lindahl equilibrium. Okay, so this is Lindahl equilibrium. Okay, so just keep this story in mind and I'll give you the definition of Lindahl equilibrium. Okay, so Lindahl equilibrium consists of P1 star, P2 star. Again, I'm assuming Px star, which is the price of the private good, is 1. Okay, so that's a numerator. Okay, and what is P1 star? P1 star is the price per unit of public good paid by consumer 1, and P2 star is the price per unit of public good paid by consumer 2. So they are charged differently. Okay, they can be charged differently. Okay, I mean, it's possible that these are the same, but it's also possible they are different. Okay, so that's why I'm calling them, these are the individual prices of each individual. Okay, that that they have to pay for the public good. Okay, so P1 star, P2 star, X1 star, X2 star, G star. Okay, so these individualized prices and this allocation constitute the Lindahl equilibrium. Okay, okay, if the following holds. So again, we are going to write the firm's profit maximization problem first. Okay, because we'll be needing the profit shares. Okay, so first, given P1 star, P2 star. Okay, so given the prices, again, always we are talking about price taking firms whenever we are talking about competitive equilibrium. Okay, we'll take that as given. Okay, so given P1 star, P2 star, the firm maximizes profit at G star and omega 1 plus omega 2 minus x1 star minus x2 star. It's the same thing. Okay, so so firm maximizes profit. Okay, so G star omega 1 plus omega 2 minus x1 star minus x2 star. So this pair solves the following maximization problem, profit maximization problem. Maximize with respect to G and x naught. Okay, so this x naught, the solution should be this one. Okay, so G x naught is, so what is the price that the firm will get? Anybody? So what is the price that the firm will get in this case if P1 star is paid by consumer 1, P2 star is paid by consumer 2? Anybody? Very good. P1 plus P2, absolutely. Okay. So P1 star plus P2 star into G minus x naught into the price of x, which is 1. Okay, so this is the profit. Okay, and of course you have a constraint, which is G must be less than or equal to fx naught. Okay, and the non-negativity constraint applies. Okay, so this is the profit maximization of the firm, and this should be the solution. Okay, now once you have this, now we are going to write the utility maximization problem of the firm. Again, let pi star be the optimal profit. Okay, so which is P1 star plus P2 star times G star minus the cost, which is this omega 1 plus omega 2 minus x1 star minus x2 star. Okay, so let me call this pi star. Okay, so now what is the second requirement? That each individual should be maximizing his utility. Okay, given the price. Okay, so given P1 star, individual 1 should be maximizing his utility, because P1 star is the price paid by 1. Okay, So he's just going to take this as given, and he's going to choose the optimal amount of G. Okay, so what should be the optimal choice of G given P1 star? It should be exactly G star. So both consumers should be maximizing their utility at the same level of G star. Okay, so notice that in this case, we are not really saying that individual one will buy G1 separately, individual 2 will buy individual G2 separately. No, we are saying that they'll pay whatever price is meant for them, so that demand equals supply. Okay, but they both demand the same amount of G. Okay, so if they both demand the same amount of G, and this firm is going to collect the sum of the price and is willing to supply the exact same amount of G, then we have an equilibrium. Okay, so let me just write that out. Okay, so given P1 star, G star, and X1 star. Okay, so these are the two components of the solution to the utility maximization problem, right? X1 star, G star solves consumer one's utility maximization problem. So what is consumer one's utility maximization problem? Maximize with respect to X1G, U1 X1G subject to the constraint that P1 star G, so this is the expenditure on the public good, okay, plus the expenditure on the private good, which is X1, should be less than or equal to the value of the endowment, which is omega 1, plus the share of the profit, which is theta 1 pi star. Okay, and the non-negativity constraint. Okay, so this should be the solution to this problem. Okay, and now you can do the same thing for individual 2. So instead of doing that, let me put I here. Okay, so this is the same problem for individual 2. Okay, so given pi star, this is the solution. Okay, so that's it. So notice that demand equal to supply is implicit in this. Okay, so all the firm is taking a decision in such a way that it maximizes profit, and it wish to supply G star, and the same G star should be demanded by the consumer. So the prices should be such that the demand and the supply must be the same. Okay, so it's just so we don't have to write that again. We can just we automatically have it, okay, in the definition. Okay, is that fine? Okay, now let's solve for Lindhal equilibrium. Okay, let's see what are we going to get. Let's use the same problem that we just did, where we found the competitive equilibrium. Now we're going to find the Lindhal equilibrium. Okay, so let me just write the utility function again. So if you remember, it was u1 x1 g is equal to 3x1 plus 2g, and u2x2g is equal to 3x2 plus 2g. Okay, and endowments were, I think, 4 and 6. Omega 1 was 4, omega 2 was 6, and what else? Theta 1, theta 2 is 0.5. Production function is g equals fx naught equals x naught. Okay, so now let's find the Lindhal equilibrium. So again, you're going to start with the firm. So we'll be interested in P1 and P2, right? We want to find P1 and P2 such that firm and both the consumers, they firm is basically interested in supplying the same amount of public good as both the consumers want. Okay, so we want we want to find P1 and P2 such that this holds. Okay, so let's first write a profit maximization problem of the firm. So it is P1 plus P2 times G minus X naught. right? Okay, and you want to maximize this with respect to G and X naught, subject to the constraint that G must be less than or equal to Fx naught, which is actually X naught. Okay, so you want to solve this problem. Okay, so again, you can rule out the possibility of zero prices, because when there is a zero price, then consumers would want to demand infinite amount of public good, and the firm would want to supply zero units of public good, so that won't be possible. For positive prices, again, you can just check that, when P1 plus P2 is greater than 1, then firm would want to supply infinite amount of public good, but then there is only finite amount of private good available. So clearly market will never clear when P1 plus P2 is greater than 1. So there are only two possibilities when the market can clear. So we just have to inspect those possibilities. So one is P1 plus P2 is less than 1, and the other is P1 plus P2 equal to 1. Okay, so when P1 plus P2 is less than 1, then the amount of public good that you want to supply will be 0, right? G will be 0. So because of the same reason. Okay, and if P1 plus P2 is equal to 1, then you are willing to supply any amount of public good from 0 to infinity, whatever is demanded. Okay, and notice that in this case, profit, in both these cases, profit is 0. So again, we don't have to bother about these shares. Okay, so now you can easily solve this. Okay, it's not difficult at all. You can just write the utility maximization problem of the consumers, and figure out what will happen. Okay, so if you see, the utility maximization problem of consumer 1 is maximized with respect to X1 and G. Okay, 3X1 plus 2G. Okay, subject to the constraint that P1G, okay, because that's the price that individual 1 pays per unit for the public good, plus X1 must be, well, I can just straight away write equal to sign, because the utility is increasing in X1 and G, so the constraint will bind. Okay, so I can write this as omega 1 is 4 in our case. Okay, plus the profit is 0. So so this is the problem that we'll be interested in solving. Okay, so again, you can just easily check that you'll be comparing P1 with 2 by 3. Okay, so if P1 is less than 2 by 3, you can always plot the indifference curve and the budget constraint to see that this is the comparison that you'll be making. Okay, so if P1 is less than 2 by 3, then you would want to spend all your money on public good. Okay, so then G will be equal to what? G will be equal to 4 by P1. Okay, and if P1 is equal to 2 by 3, then you would want to you are kind of indifferent between choosing anywhere on the budget line. So so basically, if you want to write a set, you can write it like this. It's anything between 0 and 4 by P1. Okay, and if P1 is greater than 2 by 3, then it's just going to be one possibility, which is 0. Okay, so this is the demand of public good by individual 1. Okay, similarly, you can write the demand function for individual 2. Okay, so this is for individual 1. Okay, this is the firm supply. Okay, this is supply decision. Okay, and now I'm going to write for individual 2. Okay, for individual 2, it's the same problem. The only difference is you'll have 6 here. Okay, so I can just quickly write this. So you're going to get 6 by P2, because that's the price per unit that is paid by individual 2. So P2 less than 2 by 3, it's 6 by P2. it's 0 to 6 by P2 if P2 is 2 by 3, and it is 0 if P2 is greater than 2 by 3. Okay. Now all that you have to do is you just have to figure out P1 and P2 such that the supply by the firm is equal to the demand for the public good by individual one is equal to the demand for public good by individual two. Okay. Okay, so let's do this. Okay. Now notice that if P1 plus P2 is less than 1, demand can never equal supply. The reason is because if P1 plus P2 is less than 1, definitely, one of the two prices must be less than 2 by 3. It is impossible that both P1 and P2 are greater than or equal to 2 by 3 and P1 plus P2 is less than 1. That's not possible, right? So if P1 plus P2 is less than 1, at least one of the individual will be facing a price less than 2 by 3. And if that happens, that particular individual will be demanding positive amount of public good. And the supply of public good in this situation is 0. So the market can never clear if P1 plus P2 is less than 1. Okay, so that's ruled out. So you can see here, we have ruled out the scenario where P1 plus P2 is less than 1. Is that okay? Make sense? Okay, very good. So now the other possibility is P1 plus P2 equal to 1. Okay, so P1 plus P2 equal to 1. Now this is something that you can either plot it and do it, because we don't have to really think about the firm, because firm is willing to supply any amount of public good in this scenario. So all that we have to do is we just have to figure out what pair of price P1 at what pair of price P1 P2 the amount of public good that is demanded by individual one is equal to the amount of public good that is demanded by individual two. That's all that we need to do, because once we have the same demand of individual one and two, then we can just tell the firm to supply that much, and that's it. Okay. So how do we do that? Well, you can either plot this and do it, or you can simply do this by doing these inspection. Okay, doing the inspection of these cases. So let me just quickly, so what do you want? Do you want me to plot it and do it, or do you want me to do this by inspection? Okay, plot. Okay, so what you can do is you can just draw two curves like this. Okay, so in this direction P1 is increasing, in this direction P2 is increasing, and this length is P1 plus P2 equal to 1. Okay, so this point is basically tells you that this is P1 and this is P2. Okay, so this is P1, this is P2. Okay, similarly this point again will mean that this is P1 and this is P2. Okay, so so it's just like the Edgeworth line. Okay, so on the vertical axis we'll plot the demand for public good. Okay, so the demand for public good. Okay, so first let's plot the demand for public good by individual one. Okay, so the demand for public good by individual one will be like this. It's for P1 less than 2 by 3, it is going to be 4 by P1. Okay, so 4 by P1 will look like this. Okay, it's falling in P1. Okay, right? And at 2 by 3 it is going to be 4 by 2 by 3, which is, what is 4 by 2 by 3? 6. Okay, is that fine? Okay, and at 2 by 3 you are indifferent between 0 to 4, So you'll plot it like this, because you're indifferent between 0 to 4 by P1, which is 2 by 3 in our case, so it's just 6. 4 by P1 is 6. So you're indifferent between 0 and 6, and then for P1 greater than 2 by 3 it is 0. Okay, so basically this is how you can plot the demand of individual 1. Okay, now you can also plot the demand for demand by individual 2 in exactly the same way. Notice that P2 is increasing in this direction, so you'll get a graph from here. Okay, so first let's calculate at 2 by 3 what is this term. So at 2 by 3, so 6 by 2 by 3 is what? 18 by 2, 9. Is that 9? Okay, so when P1 is 1 by 3, P2 is 2 by 3. So at 9 it will be what? At 9, sorry. Okay, just a minute. So at P2 equal to 2 by 3, at P2 equal to 2 by 3, this term will be 9. So basically at this point, we'll put 9 somewhere here. So we need to check whether 9 is above this or below this. Okay, so how do we check that? Well, you can see at 1 by 3, what is this value? At 1 by 3, this value is 12, right? At 1 by 3, this value is 12. So this curve is above, so this is 12, this is 9. Okay, so this is 9, this is 12. Okay, so basically if you want to plot it, you'll get something similar like this. Okay, and this is the point which is going to give you the Lindahl equilibrium, because this is where both demand the same amount of public good. Yes or no? Okay, so basically it lies on this curve, 4 by P1, 6 by P2. So all that you have to do is set 4 by P1 equal to 6 by P2, 4 by P1 equal to 6 by P2, and you will get and then you just have to solve the system of equations for P1 and P2. Okay, so let's just quickly do that. So this is going to give you what? P1 by P2 equal to P1 by P2 equal to 2 by 3. Okay, so that means P1 is 2 by 5 because it's just 2 by 3. So you can just add 1 to it, and then you'll get P1 plus P2 by P2. So that's just going to give you P1 equal to 2 by 5 and P2 equal to 3 by 5. Right? Yes or no? Okay, and what is the allocation? Okay, so if P1 is 2 by 5, what is this G? Okay, so we'll have to figure out this G. So all that you have to do is just substitute it here, because 4 by P1 or 6 by P2 will give you the same thing, which is G. So 4 by 2 by 5 is, so G star is 4 by 2 by 5, 20, 10. Are we getting 10? Yes. So G star is 10. Okay, and what is X1 star? X1 star is what? 0, because you pay 2 by 5 times 10, which is basically 4. So X1 star is equal to X2 star is equal to 0. Okay. Okay, notice that even though both started with different endowments, but they ended up on the same same point. Okay, the reason is because this guy ended up paying more. Okay, this wouldn't have happened if this intersection would have take place somewhere here. Okay, but anyways, it doesn't matter. Okay, so the key thing is that you know. you know, uh, 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 you Yeah, so the key thing here is this, that these are your Lindahl equilibrium prices or taxes, and this is so basically this is the share of total cost of public good provision that is paid by one. This is the share that is paid by two, and the total amount of public good that is provided in this economy is 10 units. Okay, and you can check that this is efficient. Okay, this is per unit efficient because we have already seen that. Okay, so it's just the top of the triangle. Okay, so this is per unit efficient. Okay, is that clear? So it turns out that Lindhal equilibrium will be per unit efficient. Okay, I mean, the reason is, as we have seen, that these guys are paying the fraction. Okay, they're not paying the per unit price of public good. Okay, which is P1 plus P2. They are paying some fraction of it. Okay, so this is a reason why you end up getting efficient allocation in this case. Of course, we are assuming a monotonicity of the utility function uh, that is required, because otherwise we can construct situations where this may not happen. Okay, the equilibrium may not be efficient. Okay, yeah, so I hope this was clear. So you can try the quasi linear yourself. So we can stop here for today.